Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Aqila binti Ahmad. Today I want to present about the importance of equatorial and topocentric coordinate systems in facilitate astronomers and amateurs to locate an object in the sky. Okay. Before we know about the importance of equatorial and topocentric coordinate system, we must know who is astronomer and amateur. Okay. Astronomer is a scientist in the field of astronomy who focuses their studies on a specific questions or field outside the scope of Earth. They observe astronomical objects such as stars, planets, moons, comets, and galaxies in either observational, that's meant by analyzing the data, or theoretical astronomy. Okay, next we move to amateur. Amateur astronomy is a hobby where participants enjoy observing or imaging celestial objects in the sky using the unaided eye, binoculars, or telescopes. Amateur astronomers typically view the sky at night when most celestial objects and astronomical events are visible, but others observe during the daytime by viewing the sun and solar eclipses. Some simply verify the sky using nothing more than their eyes or binoculars. However, a lot of dedicated amateurs typically use movable telescopes or telescopes situated in their private or club observatories. The issue is about the importance of equatorial and topocentric coordinate systems in facilitate astronomers and amateurs to locate an object in the sky. There are many things in both coordinate systems that help astronomers and amateurs to locate an object in the sky. First, equatorial coordinate system. Astronomy developed the equatorial coordinate system in order to be precise and accurate in determining a location on the sky. Astronomers imagine that the Earth surrounded by a large sphere called the celestial sphere. The Earth equator and also the plane of Earth orbit are projected onto this sphere. The celestial sphere is the concept of the celestial equatorial coordinate system. This is a diagram of right ascension and declination of equatorial coordinate system. Okay. First, declination. Declination, abbreviated as DEC. Declination is similar to latitude and is measured in degrees, arc minutes, and arcseconds north or south of the celestial equator. Positive values for declination correspond to positions north of the equator, while negative values refer to positions south of the equator. Even declination does not use the designation N and S, latitude and declination are nonetheless closely related to coordinates. The positions of an object is stated with the right ascension first, then the declination. Second, right ascension. Right ascension, abbreviated as RA. Right ascension is a coordinate on the celestial sphere that is similar to, but not identical to, longitude on the Earth's surface. Right ascension also has a zero reference point, and that point is the vernal equinox point. Right ascension, consequently, is measured in sidereal hours, 0 hour to 24 hours is from the vernal equinox point. That is, it is the direction of increasing right ascension. The half circle with right ascension 0 hour is called the 0 hour circle. As a circle is 360 degrees, 1 hour right ascension equal to 15 degrees. Next, the topocentric coordinate system. Topocentric coordinate system is an easier coordinate system available for amateur astronomy. It's also known as horizontal coordinate system and ALT/AZ system. A celestial coordinate system that uses the observer's local horizon as the fundamental plane, and the topocentric coordinate system is also a method for describing the exact positions of objects in the sky, such as planets, the sun, or the moon. Coordinates of an object in the sky are expressed in terms of altitude or elevation, angle, and azimuth. This celestial coordinate system divides the sky into two hemispheres. First, the upper hemisphere, where objects above the horizon are visible. Second, the lower hemisphere, where objects below the horizon cannot be seen since the Earth obstructs views of them. The great circle separating the hemisphere is called the celestial horizon, which is defined as the great circle on the celestial sphere whose plane is normal to the local gravity vector. Okay. The topocentric coordinate system provides altitude and azimuth angles to locate objects in the sky. First, altitude or elevation is the angle the object makes with the horizon. Objects that seem to touch the horizon have an altitude of 0 degrees, while those straight above observer are at 90 degrees. Anything below the horizon has a negative angle with negative 90 degrees, describing a location straight down. The location straight above observer is called zenith, while the point exactly below observer is referred to as nadir. Azimuth is the object's cardinal direction, such as north, east, south, or west. It is specified as the horizontal angle the object makes with a reference direction. The azimuth is the angle between the spot where that line crosses the horizon and the reference direction. If true north is used as reference, it is represented by an azimuth of 0 degrees and angle values increase towards the east. Okay. In the conclusion, the equatorial and topocentric coordinate systems are very important in facilitating astronomers and amateurs to locate objects in the sky. The equatorial and topocentric coordinate systems are two different coordinate systems, but in general, these two coordinate systems have the same function, which is to facilitate astronomers and amateurs in finding and locating an object in the sky. That's all from me. Thank you.